Welcome back to our Neo Protocol Smart Contract series. What if I told you there's one data structure that separates amateur smart contracts from professional DeFi protocols, handling billions in TVL? Today we are diving into Hashmap, a powerful data structure that stores key value pairs for fast lookups. Unlike arrays that use numeric indexes, Hashmap lets you use any type as a key to store and retrieve data instantly. This is perfect for smart contracts, where you need to associate data with your user accounts, token IDs, or any unique identifiers. Let's explore how to use Hashmap in practical smart contract scenarios. First, we need to understand when to use Hashmap versus array is crucial for efficient smart contract design. Use Hashmap when you need to look up data by unique identifiers. The keys are not numbers like account names, transaction hashes, or maybe some custom IDs. You frequently add, remove, or update individual entries, and order doesn't matter for you. Use arrays when you have fixed known number of elements. You need to access elements by position, so like first, last, or middle, and memory efficient is crucial. Hashmap usually used in smart contract for user balances, NFT ownership, allowance, and marketplace listing. The key insight: Hashmap trades memory for speed and flexibility. When you need to find data by key instead of get element at position, Hashmap is your best choice. So let's start with our smart contract functions to show Hashmap basic functions. For this we'll create our function, public function, manage user balance, and in the end we'll return string. So let's create our Hashmap. Let's mutable our user balances, Hashmap. After that we write our data type. Let's be string and U64. So first element it should be string, another element should be a number, and the last element just write new. So let's add some elements to our Hashmap. For this we'll write user balances dot insert. Instead of adding arrays we write insert here, and here we should be string. Let's write an address, for example list.near. Also we need to convert it to string. After that we need to write a number, let's be 1000, and let's add 2 elements more, Bob, and let's be Charlie. And here will be, for example, 500, and here in the middle 750. Okay, let's show you how to get the balance, to get the value from the Hashmap. Let's get a list balance, and for this we need to write our user balances dot get. Here we write a list near because we are looking for a list.near, and in the final we need to write also unwrap or ampersand and 0. This means if, for example, we don't have a list.near, so default number will be 0. For example, if we don't write unwrap or, our function will panic because program cannot find the list.near and you will get an error. That's why, to prevent the error, you just write unwrap or and write ampersand and the number or another something of the default value. Also, I will show definitely how to update existing balance, update the values in the Hashmap. You just override previous value. So if I will write here and, for example, let's be 1200. So right now, list.near will be 1200. It just overrides the previous value. And the last operation of this function, it will be check if user exists in our system. So check if this value exists in the Hashmap. So let's check our Bob. Let's just write let hasBob user balances, and here we write contains key and write what value we are looking for. I'm looking for bob.near. So it will just return you true or false. That's all for Hashmap basic functions. Let's move on for advanced Hashmap operations. For this I will create another function. It will be public function manage NFT, let's be, and oops, I forgot the brackets, and we also return string. So let's create one more time the Hashmap. U32 to strings or string. Right now we have opposite. First value is a number and the second is text. So let's add some NFTs in our Hashmap. Let's just write NFT owners. We remember from previous functions that to add some values, it's insert. Here let's just write one. This will be alice.near, and of course to string. Let's just copy it. Let's 2, 3, and 4. Let's here will be Bob. Let's keep Alice, no problem. Alice can have 2 NFTs. So one of the operations that we will start is count the total NFTs in collection. So count total values in the Hashmap. For this, let's write let total NFTs equal NFT owners dot len. Basically the same as in arrays. The other operation is how to remove the element from the Hashmap. In our case, just remove NFT, burn operation. So let's write burn NFT. It just will return you what NFT, what the value we just removed. So basically it's nothing complicated here. Write NFT owners, our Hashmap, remove, and here we write ampersand, it's mandatory, and write the element 2. So we just remove the bob.near. Or for example, if there will be no value by 2, so it will just return none. These advanced operations show Hashmap's real power in smart contracts. I will repeat, the remove method is practically useful if deletes any entry and returns the removed value as an option. If the key existed, you get some value. If not, you just get none. This is perfect for burn operations where you want to confirm what was actually removed. So before we will interact with our smart contract, I will just add some interface for our terminal. Don't worry about new code. All code will be in the GitHub. You can just copy it. It doesn't matter for your case. All code that we wrote before, it's working perfectly. So it's just for interface for terminal. So let's interact with our smart contract. Yep, let's check. Let's go for first manage NFT. JSON args, we have nothing to put inside. Testnet, no. Yep, you can see total, the length is 4. Bird NFT number 2 is Bob, because here is a value 2, and it's Bob, so returns Bob. So it works properly. Let's check another function. Also here nothing to put inside, it's empty. Testnet, no. Yeah, you can see first alice.near balance it was 1000. After that updated balances is 1200, and if Bob exists, yes, it's true, because bob.near exists here because we add this value. So that's Hashmap in Near Protocol smart contracts. The key takeaway: Hashmap is your go-to choice when you need fast lookups by unique keys rather than numeric position. It's perfect for user balances, token ownership, and any scenario where you're mapping identifiers to data. Choose Hashmap for flexibility and speed, arrays for fixed size ordered data. Want to code like a pro in top DeFi platforms? Subscribe now and turn on notifications so you will not miss our upcoming advanced tutorials. See you next time.